we discussed about the RMF, that is a rotating magnetic field. And the rotating magnetic field, so we discussed about the phasor diagram for different angles. Okay, so the rotating magnetic field will be generated at the stator side, and it will have the speed nearer to the synchronous speed. So for that, how the rotating magnetic field are developed, what is the magnitude of the flux? We derived with the help of phasor diagram. For three angles we derived. Similarly, we can derive for other angles also. So theta equal to 0, 30, and 60. So it may be any angle. The magnitude of the resultant flux, that is the flux generated in the stator, will be almost, Sanjay. So it will be almost constant. Okay. So what is its magnitude? It will be for any angle. If you check means the magnitude will be resultant flux will be 1.5 pi m. Okay. And next we discussed about the equivalent circuit of the induction motor. So the equivalent circuit will be remains similar to the transformer, except load. So we'll have the load part will be will include the slip. So at the rotor side, we'll have a small change in the parameters by the inclusion of the slip. So we obtained the final equivalent circuit. With that, we are having some more expressions related to the equivalent circuit. So what is the role of this equivalent circuit? Means to know the parameters of a particular machine. Want to know the stator parameter, rotor parameters, and no load loss component, and there is a no load means core loss component, and copper loss component. If you want to know means from this equivalent circuit you can obtain the exact value for the different parameters of the induction motor. And here, so similar to transformer, we'll have a constant K. In the case of transformer, we'll tell that so K is the transformation ratio. But as per the induction machine, so you may represent as a K or a small a. The K is called as turns ratio or rotor to stator ratio. So that may be, here we are not using the term transformation ratio. So we'll generally we'll consider that K as a ratio between the rotor and the stator. So that is you may have the notation of the equivalent circuit will be different in different textbooks. So no need to confuse. You can follow a single book, so that will not confuse the notations. Okay. So each and every book will have different notations. So no need to confuse. You follow a single book, so that the notation of the transformer and the induction motor will be same. Okay. So with that equivalent circuit, from the final equivalent circuit, we'll have some more equation we'll discuss. Okay. So you take down all this formula. After completing this topic, we are going to solve two problems. That problems may appear in the 10-mark questions or 16-mark question. So you take the final equivalent circuit. So this is the equivalent circuit if you are referring all the parameters to the primary side. Okay. So here only this rotor only will have a difference. Remaining all the parts will be similar to the transformer. So this is the supply voltage, input current, input resistance, input reactance. This is the core loss component. So this is the no load current. And this is a core loss component. This is a magnetizing loss component. And this is the reference from the rotor to stator. So the EMF on the of the rotor to refer to the stator, and these are all the parameters refers to the stator. So this and all you discussed this already. Sir discussed in the transformer itself. So what is the relationship? So here we'll have this V2 by V1 equal to N2 by N1 equal to I1 by I2 equal to E2 by 1. So here you may use a K or A value. So this is the ratio between the stator, rotor and stator as per the induction motor is concerned. And here this is the load available on the rotor side. And so generally we'll have a general term will be R2 by S. So this is the term we used. So after simplifying, you will get the final expression for the load. So will be R2 by K squared into 1 by S minus 1. And R2 by K squared will be called as R2 dash. So this is the final equation. Our final equivalent circuit referred to the stator side. So with this, we are going to obtain the what is the gross mechanical power generated. That is we have a gross torque. So if you are having any motor means we can say DC motor. So you will represent the torque is phi into Ia. If it is a shunt motor, torque into phi Ia squared. So in the case of the series motor, so like that we will have some expression. So in the case of induction motor, we are going to derive the torque expression. So first one, the total electrical load. So this is the load. You can write this equation. So RL dash is equal to R2 by K squared into 1 by S minus 1. This is the load plus R2 dash. And you can write this as a R2 dash by S. Okay. So these two parameters you are adding. Okay. So if you refer the first equivalent circuit, so we'll have only the impedance and the resistance. We'll convert it in like this. We'll have two terms. We'll have a fixed resistance and a variable resistance with respect to the slip. And this is the total electrical load. And the power input to the stator. What is the power input to the stator? We have three phase power V1, I1, cos phi 1. Okay. So this is the power input to the stator. And the third one, rotor input. So here, what are the stages here we are having means? So we'll have a stator, and then we'll have a rotor. In the stator, we'll apply a three-phase input. So we'll call this as a power input. This is a power input. And afterwards, we'll have the load. So this is a stator and this is a rotor. Okay. So we'll apply a power input to this. So the flux will link with the rotor, and we'll have a rotor input. So here we'll have some losses. We'll have core losses and the copper losses. So we'll give the input, and if we subtract these losses, we'll get the rotor input. Okay. So the power input, if you subtract the power input, power in minus power losses in the stator. If you subtract means you'll get this rotor input. And here in the rotor we'll have again losses, and if you subtract these losses means you will get the mechanical output. So what is the rotor input means? So we'll have 3I2 double dash square R2 dash by S. So here we'll have the input current to the rotor will be I2 double dash. Okay. So that is a three phase. We'll have a 3 I square R divided by S. Okay, that is what is R2 dash by S will be the rotor input. Okay, and next rotor copper loss. So you know the formula for the copper loss will be I square R. This is a three phase. Will have a 3 I2 double dash squared into R. So R2 dash. Okay. So here everything we are writing with respect to rotor. So what are the notations we are using on the rotor side we have to use. So I square R. So rotor side means I2 square R. So I2 double dash R2 dash. So into 3. So this is the power input to the rotor. This is the rotor copper loss. And next mechanical power. So what is the mechanical power means? Rotor input minus rotor copper loss. So substitute the value 3 I2 double dash squared R2 dash minus R2, and you take the common terms outside. Check means you will get 1 minus S minus 1. And this again you can write this expression as like this also. I2 double dash squared R2 dash into 1 minus S divided by S also you can write. So this is the mechanical power. So in the case of DC, we'll have output power equation. So generally in the, what is the output power means? Output power, so can have so 2 pi NT by 60. This is the output power generally we express. So with this reference to this equation, you can write the mechanical power developed is equal to 2 pi N TG divided by 60. So what is this? TG represents, PM represents the mechanical power and TG represents the gross torque developed by the induction motor. And here you can substitute the PM value available here. So PM is equal to 3 I2 double dash square R2 dash into 1 by S minus 1. So this will be equal to 2 pi N TG by 60. Okay. Again, we are rearranging this equation as 1 minus S divided by S. So into 3 I2 double dash squared into R2. So this is equal to 2 pi N. So N we can write as NS into 1 minus S. So from the slip formula, so from this formula you can write this expression as so N is equal to NS into, so that NS into 1 minus S into TG divided by 60. And you can cancel the common terms. This 1 minus S you can cancel. This 2 1 minus S you can cancel. And then you can, from this expression, you can write the TG. TG equal to P I2 double dash squared R2 by S divided by 2 pi NS divided by 60. Okay. And you consider the constant term. What are the constant terms available? Means 2 pi 60 is 3. And if you make as a whole number, so you will get TG will be equal to 9.55 3 I2 double dash square R2 dash by S divided by NS. So you keep the variable terms separately, and 3 this 2 pi and 60. If we divide means you will get to 9.55. So remaining terms will be 3 I2 dash square R2 dash by S divided by NS. So this is the final gross torque developed by the induction motor. So unit will be Newton meter. So are you having any doubt in this expression? So you can take the notes. Some expressions will not be available in the PPT, or you have to refer so many books. Okay. So are you clear with this? So the total electrical load will be the load available in the equivalent circuit. So this and input will be 3 VI cos phi, and this is a rotor input. So electrical load rotor input will be the output of the stator after subtracting the losses. So output of the stator will be equal to the rotor input. And this expression, and if you subtract the rotor copper loss, this is a 3 I square R, it is a 3 phase, then you will get a mechanical power. And if you subtract these two terms, means you will get the final mechanical power. And you know the output power, so general formula will be 2 pi NT by 60. From this, we are going to calculate this torque only. That is called as a gross torque. And you substitute the mechanical equation here, mechanical power equation, and this will be equal to the output power. And if you simplify and you have the constant, then you will get the final expression. So in this expression, if we copy it, means we will move to the problem. Are you any doubt? Call the answer pannunga. So not having any doubt. Okay, if we copy it, means we will move to the problem. So we'll have two problems. We'll solve the problem. So this I2 dash, I2 double dash, R2 dash, it will be vary from one textbook to another textbook. So you can follow the only one textbook. If you follow, means the notation will not confuse. Our not means we are referring to different textbooks, means you will get confused. Okay. So you take the first problem. Final expression will be 9.55 into 3 I2 double dash square R2 dash by S divided by NS. So this will be the final expression. Gross torque is equal to 9.55 3 I2 double dash square R2 dash by S divided by NS. Roban, now it's okay. Okay, you take the first problem. A 400 volt 50 hertz 3-phase star connected induction motor has per phase stator impedance. So Z1 equal to 0.07 plus J 0.3 ohm and per phase rotor impedance referred to stator. So Z2 dash is equal to 0.08 plus J3 ohm. The per phase magnetizing reactance is 10 ohm and resistance representing core loss is 50 ohm. The slip is 4%. So using approximate equivalent circuit, find stator current and stator power factor, developed torque, gross torque. So this is the TG is the gross torque. Okay. So you have to calculate the stator current. What is the notation for stator current? So I1. Then you have to calculate the stator power factor and develop the torque, and you have to calculate the gross efficiency. So you can refer the equivalent circuit or you can draw the equivalent circuit also. If having any doubt means you can draw the equivalent circuit. From that we will solve the problem. You write the given data, you can draw the equivalent circuit. And what are the parameters given? So R1 is given as 0.7 ohm. So X1 is equal to 0.3 ohm. R2 dash, so 0.08 ohm. So X2 dash 0.3 ohm. So it is given in terms of Z value. So you can find the value from the Z. So Z equal to 0.07 plus J 0.3. Z2 equal to 0.08 plus J 0.3 ohm. From this you can write the R1 X1, R2 dash, X2 dash. So first you are supposed to calculate the stator current. Okay. Stator current and stator power factor. So what is the expression for stator current? So we'll have I1. So from the equivalent circuit, if you refer means, so input will have I1, then we'll have a no load current, then we'll have a rotor current. So it may be I2 dash or I2 double dash. So this is the input current. It will be divided into I0 plus I2 dash. So you can write the I1 is equal to I2 dash plus I0. So what is I2 double dash? It is a rotor current referred to stator, and this is the no load loss component current. Okay. This is the first subdivision you are supposed to solve. Okay. Stator current we are supposed to calculate. And what is the formula for I0? So I0 you can give as IW plus IM or IC plus IM. You will have W or IC, anything. And you can write this as a V1 by RC. And this you can write as V1 by JXM. So yeah, you will have a tank circuit like this. And here, so the current entering, this will be IW and the current entering will be IM. Okay. This value will be RC, this will be XM. We have a J value. Okay. So from these expressions, they are writing this equation V1 by RC. So what is the input here? We'll have V1 will be the input. So V1 by RC plus V1 divided by JXM. Then coming to I2 dash, how to calculate the I2 dash means, so we'll have V1 divided by that is the input voltage R1 plus R2 dash plus RL dash plus J X1 plus X2 dash. So if we are finding the I2 dash value means we will have a total voltage divided by total resistance and the reactance of the circuit. What are the total resistance we are having? R1 stator, rotor R2 dash load, and next we will have a stator reactance, rotor reactance referred to stator. So now you substitute the value and you can find the term. So here we have how to calculate. So what is the value for V1 means? So what is the parameter given voltage? The voltage V is given as a 400 volt. So in the case of equivalent circuit, so we will generally find the value for per phase only. All the parameters will be given per phase only. So if we are converting this to per phase means what is the thing we have to do? We have to divide 400 by root 3. So this is the rotor resistance, stator resistance per phase, stator resistance, reactance per phase, rotor resistance per phase. All the parameters are per phase only. Okay. So initially we will convert this voltage, you divide by root 3 and you will get the per phase voltage. And then RL dash here, this value, we will have the formula. What is the formula we have? So R2 dash into 1 by S minus 1. So what is the slip value given? So slip is 4%, it is given. So now you try to solve, you calculate one by one. You calculate V1, then you find the RL dash, then you find the I2 dash, then you find I0, then you can calculate the I1. You try to solve. If you are having any doubt means you post in chat box. Or you unmute and ask me. So you can tell one by one, you can tell V1 value first, and then you can tell RL dash value. Then you calculate the I2 dash. After calculating, you post on the chat box. So okay, V1, Venkatesan, okay, correct, 230, 230.94. Then you tell the value for RL dash. The next problem you are supposed to solve. I will solve only one problem. In slip, you have to substitute 4 or 0.4. That you should be clear. So you should substitute 4 or 0.4. So in the place of slip, you have to substitute 0.04 only, not 4. What is the value for RL dash? 0.064. You check the answer. So R2 dash is 0.08. So this is the value you are supposed to substitute 0.08 into 1 by 0.04 minus 1. So tell the answer for this. 1.92 is correct answer. 1.92 will be the correct answer. Okay. So next you find the value for I2 dash. So here you will have this conversion and all rectangular to polar and then convert panni you tell the answer. For I2 dash you have to substitute the value like this. So I2 dash equal to 230.94. So divided by R1 value 0.07 plus 0.08 plus 1.92 plus J point 3 and this is x2 dash is 0.3, 0.31. So 0.3 plus 0.3. And here it will have an angle 0 degree. And you solve and tell the answer. So in mobile it's not possible to do, I think. If you should have calculator. Even in the message போட்டேன் calculator எடுத்துட்டு வாங்க. One not 2.49. What about angle? You should have an angle also, no? The magnitude is 102. What about the angle? Sumant Reddy. 102, 29 degree. Yeah. So any other answer? One not 2 degree 29. Are you getting any other answer for this? You check, are you getting this value? 107 angle minus 16.2 degree. Okay, 106 Venkatesan, okay, it's okay. 106.8, that is 107. So angle minus 16.1, okay. You check the answer, it should be nearer to 107, angle should be minus 16 degree. So next you can calculate I naught, sorry, I1. So you calculate I naught, afterwards you can calculate the I1. So I naught is equal to V1 by plus V1 by JXM. So what is the value of RC and RC given? And the XM is 10 ohm. So RC will be, core loss component will be 50 ohm. And again here you can substitute. So 230.94 angle 0 degree divided by 50 plus 10. And you tell the value for I naught. You tell in the polar format. Okay. So like this, in polar form, you have the value, magnitude and angle. You tell the answer. Here you have to include J. So it is a value 27.7. What about angle? You will get angle also. What about angle? Angle 0. So either you should get a X plus JY format or magnitude and angle, either rectangular format or polar. So any other answer? So if we want to simplify this means you can rearrange the equation like this also. 230.94 angle 0 divided by 50. You can bring this J term to the numerator, you will get minus J. 230.94 angle 0 divided by 10. So like this also you can rearrange the equation and you can find. So any other answer for this I naught? So I naught should be either 4.6 minus J 23 amps or 23.4 angle minus 79 degree. You check this answer once again. No one is getting this answer. So like this, if we frame means this angle you can remove. So this is in polar form. So we are converted this to rectangular, then the angle will not come, and we will have 230.94 divided by 50 minus j, 230.94 divided by 10. So no need to worry about this angle. Now you check for this, you calculate or getting this value, tell. For this value or getting this final output 4.61 j. Okay. You will get this answer. So you will have a small change in the decimal. No theory. So if it is closer to 4.6 J23 means okay. Okay, Kishore, okay, correct answer. Okay, so you can convert that to rectangular format, you will get this value. So next, we'll go for the I1. I1 is equal to I2 dash plus I0. And you substitute the value here. So what is the I2 dash value? 107 angle minus 16.2 plus 23.4 angle minus 79. Then you tell the value for I1. Okay, Venkatesan, okay, correct answer. Okay, tell the value for I1. ஒரு ரெண்டு மூணு ஸ்டூடெண்ட்ஸ் ஆன்சர் போறாங்க, மற்ற ஸ்டூடெண்ட்ஸ்லாம் கொஞ்சம் ட்ரை பண்ணுங்க. For example, இந்த rectangular to polarல அப்புறம் will get a wrong answer. In class itself, you try to solve and get practice. What about I1? You tell the answer, then we move to the second subdivision. One not 7.2 angle 52.8. Any other answer? One not 7.2 minus 52.82. You check, are you getting this answer? 119.7 angle minus 26.3. To check this answer, you should get this value. And then as per the first subdivision, magnitude of the stator current. So magnitude of the stator current so is 119.7 amps, and power factor will be power factor equal to cos of minus 26.3. So this magnitude will be the magnitude of stator current. This will be the power factor. So you know the power factor equal to cos phi. So substitute to minus 26.3, and you will get 0.89 lakh. So this is as per the first subdivision. Okay. So stator current and stator power. And then we'll move to the second subdivision. So second subdivision, you are supposed to calculate the developed torque. Okay. And so equation is given here. Developed torque, that is a gross torque, is equal to 9.55 into PM divided by N. So you know PM is equal to 3I2 double dash squared into RL dash. So RL dash already we calculated. Okay. And you find the NS, N value, then you calculate PM and you tell the gross torque value. So you tell the answer. So what is the value for NS? என்னாச்சு யாருமே ஒரு ஆன்சரே காணும் ஒன்றும். What is the value for NS? So if you are having any doubt in the first subdivision, means afterwards you can check the answer. So you note down the answer and you continue with the second subdivision. Afterwards we can check. You can check if there is any doubt. Okay. So next you move to the second subdivision. So in the second subdivision we are supposed to calculate the developed torque. And what is the value for NS? What is the value for N? What is the mechanical power? So what is the value for N? So NS you can write 120 F by P. So this 4 pole is given. So what is the answer? You can post on the chat box. So NS on the 30. How it will be 30? So 120 into 50 then 50 divided by 4. So what you will get? 150. Now one answer. How the speed will be 150? 1500. Okay. 1500 RPM. What about n value? N. What about n? Okay, ns 1500. Okay, correct. So tell the value for n. Use this formula ns minus, sorry, this value. So ns will be 1500 into 1 minus 0.04. And you check, are you getting 1440 RPM? Then you find the PM value, 1440. Okay, correct. So PM, so you know you already calculated I2 dash, I2 double dash you already calculated. Then we'll have, you also calculated RL dash also. So what is the value for RL dash? It is 1.92. You tell the value for PM. Here you have to substitute only the magnitude value. So PM will be equal to 3 into, so this magnitude you have to consider 107 squared into, so RL dash 1.92. And what is the value for PM? PM will be equal to 6594. Okay, correct. 65946. And then you find the TG. So gross torque developed TG equal to, so 9.55 into 65946 divided by 1440 R. You tell the gross torque. Gross torque 437. Okay, correct. So gross torque will be 437.35 Newton meter. So third subdivision, we are supposed to calculate the gross efficiency. Okay. So gross efficiency will be, so PM divided by P in. So what is the mechanical power divided by the electrical power? That will use the gross efficiency. And you are supposed to calculate the power in. So power in is equal to 3 V1 I1 cos phi 1. So mechanical power will be 65946 divided by power input. So 3 into, everything will be in phase only. So 239 point something. What is the value calculated? So into I1. So I1 is equal to 119.7 into cos phi we calculated 0.89. So tell the answer for the efficiency. %86. You tell the value for P in. So P in 74305. This is the gross efficiency. $95 $86. So 95 போறீங்க 86 போறீங்க என்ன வேல்யூ வருது பவர் இன் எல்லாருக்கும் ஒரே மாதிரி வருதா வாட் அபவுட் பவர் இன் சிக்ஸ் ஃபைவ் நைன் ஃபோர் 0.6 divided by 740J305. So Venkatesan, how you are getting 95.88? So we'll get around 80 something only. 88.75. 88 point. It will be around 88 point something. So here, are you having any doubt in this problem? Because you are going to solve next problem like this only. Okay. If you are having any doubt, means you can ask. Shall we move to the next problem? All completed or not? If you are having any doubt, means you can ask me afterwards. Afterwards also, or now you can unmute and you can ask now itself. And if you are not having any doubt, means we will move to the next problem. தம்பி எதுவுமே ரியாக்ஷனே காணோம் எதுவுமே எந்த மெசேஜுமே காணோம் குரூப் எல்லாமே சால்வ் பண்ணிட்டு இருக்கீங்களா சஞ்சய் 229 சஞ்சய் இருக்கே இல்லையாப்பா ஆன் பண்ணி வச்சுட்டு போயிட்டேடா இருக்கே இல்லையா
சார்
கம்ப்ளீட் பண்ணிட்டியா
ஹலோ கேக்குதா
கேக்குதுடா எனக்கு கேக்குதா உனக்கு கேட்கலையா
கேக்குது சார்
கம்ப்ளீட் பண்ணிட்டியா கம்ப்ளீட் பண்ணிட்டியாடா
சார் போட்டுட்டு இருக்கேன் சார்
எது வரைக்கும் போட்டுட்டு இருக்க எது வரைக்கும் கம்ப்ளீட் பண்ணிருக்க இன்னும் முடிக்கலையா சரி ஓகே கம்ப்ளீட் பண்ணு So if you are completed first problem means you can try for second problem. You take the second problem and you try to solve the second problem. இதுல செகண்ட் ப்ராப்ளம் எது வரைக்கும் தெரியுதோ அது வரைக்கும் சால்வ் பண்ணு if you need additional problem additional formulas I will give the additional formulas. What are the subdivisions you know you try to solve that. If any new subdivision is available means I will give the formula for that. And you solve and you can post the answer in the chat box after completing one. If you calculate that first subdivision step means suppose speed, you post that in the group so that everyone will verify the answer. If there anything wrong means they will correct in that particular step itself. So a 400 volt 4-pole 50 hertz 3-phase star connected induction motor has the following per phase parameters referred to the data. So R1.6, X1 1.1, R2 dash 0.3, X2 dash 0.5, XM 25. The mechanical losses are 1000 watts and the stator core losses are 500 watts. The slip is 3%. So using approximate equivalent circuit, find the speed, stator current. இப்போ நம்ம அதே எப்படி போட்டோமோ அதே மாதிரி தான். First you are supposed to calculate the speed. Speed na you have to calculate n value. Okay. N speed means you should not confuse with the internal speed and the motor speed. Speed na it is always running speed only. And if you want to calculate running speed means you have to calculate synchronous speed. Then stator current means you got to calculate I1. I1 means again you'll have the formula I2 dash plus I0. And if you calculate the I1 means you can calculate the stator current and the stator power factor. And the power input to the rotor, that is the rotor input power. You'll have the formula for rotor power input. So gross torque varaikkum நம்ம calculate பண்ணிருக்கோம் previous problem. Shaft torque we are not calculated. We'll calculate. You calculate up to gross torque. Afterwards, I will tell how to calculate shaft torque. So 1400 RPM. So you check 1440 or 1455 RPM. Synchronous speed is 1500. And slip is 0.03. Slip on the 3%. So you'll get 1455 or than per. Yes, 1455 or no. So first subdivision. So NS equal to 1500 RPM. So N should be 1455 RPM. And then you solve second subdivision. Second subdivision, you are supposed to calculate I2 dash. And you tell I0, I1 value, everything you tell. To tell the value for I2 dash, (21 angle). Okay, correct answer on this. So 21.54 angle minus 8.6 amps I2 dash. Can you tell the value for I naught? I naught யாரும் calculate பண்ணலையா? I நாட்ல இருக்க டவுட் இருக்கா? So in I naught, so neglect RC ன்னு கடைசியா கொடுத்துருக்காங்க பாரு. இந்த ப்ராப்ளம் neglect RC. So RC neglect பண்ற வேண்டியதான். If you neglect means you will get the equivalent circuit like this only. So instead of tank circuit, we will get only XM மட்டும்தான் வரும். Because this RC in problem it is given as it is neglect RC. Okay. So we will get the only you will get XM. Okay. So you will have a I naught. So next, what is the formula for I naught as per this case? Na V1 divided by XM, JXM. So generally, what is the formula for I naught? I naught is equal to so IC plus IM. So we'll put the V1 divided by RC plus V1 divided by JXM. When problem it is given as you can neglect IC, then I naught will be equal to IM. So you can use only this formula to find the I naught. Now you tell the I naught value. So now you tell the I naught value. (9.2 angle 0). Now you check the answer. And 0, you should have get some angle. 0 degree will not come. Magnitude right, okay. What about angle? So in the I naught, what you are substituting? 400 divided by root 3 angle 0 divided by J 25. 10.1 angle 90. Okay. So I naught will be 9.24 angle minus 90 degree. 9.24 angle minus 90. So then you can find the I1. So I1 is equal to I2 dash plus I naught. So tell the value. So 21.54 angle minus 8.06 plus 9.24 angle minus 90. What is the value for I1? So I1 you check are getting 24.56 angle minus 30.5. Then you find the stator power factor. So is equal to cos of minus 30.5. Okay, okay. So I naught will be equal to 9.24 angle minus 90. And I1 so will be equal to 24.56 angle minus 30.5. So this is as per the subdivision 2. So third subdivision, so find the stator power factor. So stator power factor will be equal to cos phi what is the phi in I1, what is the phi value available? So that is a cos of minus 30.5 until the power factor. What is the power factor? Now you can tell the power factor. So okay, correct. So 0.86 lag. So stator power factor equal to 0.86 lag. So this is up to third subdivision. Okay. In the fourth subdivision, you find the power input to rotor. So power input to the rotor. So this is a rotor input power. So what is the formula for rotor input? Means the stator input minus stator losses. Okay. Stator input minus stator losses. What are the losses available in the stator? So we'll have both the core loss and copper loss. Okay, you write the formulas. Rotor input power is equal to stator input power minus stator losses. So you know stator input. So stator input is equal to P1, 3VI cos phi, 3VI V1 I1 cos phi 1. So stator copper losses 3 I1 square R1. Okay, and the stator core loss is given in the problem itself. So stator core loss is given as 500 watts. So first you calculate, you write this formula, rotor input equal to stator input minus stator losses. Then you write the formula for stator input and you calculate the value for stator input and you calculate the value for stator copper losses. Okay, and you substitute, you add both the stator losses means both the losses here you have to include, both the core plus copper loss. So this will give the stator loss. So now you tell the value for stator input. month ready the formula la visible irka?
சார் எனக்கு விசிபிளா இல்லை சார், எனக்கு நெட்ஒர்க் கொஞ்சம் பிரச்சனை சார். வேற
Okay,
யாராவது
okay.
கேட்டால் தெரியும் சார்.
No problem, no problem. உனக்கு எதை இஷ்யூ இருந்துச்சுன்னா நீ சொல்லலாம், ஒன்றும் பிரச்சனை இல்லை. இப்போ now these formulas what I wrote in the board is visible or not?
சார் இது நெட்வொர்க் கரெக்டா இருக்கு உங்களுக்கு தெரியுது சார்.
சரி சார்,
சிலருக்கு
சரி
கொஞ்சம் பிளர்ரா இருக்கு, கொஞ்சம் பெருசா இருக்குன்னா
சரி சார், சரி ஓகே சார், ஓகே. So yeah. So today up to this we'll solve, we'll continue with the fifth subdivision operators we'll solve. We'll solve up to fourth subdivision. So this we are going to calculate. So what is the formula for stator input? This will be 3 V1 I1 cos phi 1. So what is a 3? 400 divided by root 3. So I1 we calculated as a 24.56. 24.56 into, what is the cos phi? 0.86. And you tell the value for this stator input. The time aicha 11 o'clock aicha. So up to the stator input we will complete. So stator input you check, okay, Venkateshan correct value. So up to this we will stop. So stator input will be 14630 14637 watts. The remaining things we will continue in the next class. Okay. So you can check up to this, up to stator input we solved. Okay. So you check this answer 14637 watts. Are you getting or not? The remaining things will continue. So from fourth subdivision we will continue from the next class. Okay. So any other doubts means you can ask now. So if you are facing any problem means you just post the details in the chat box. So it will be rectified from my side. Okay. So today we discussed about the final equivalent circuit and what are the parameters involved and what is the difference between transformer and induction motor equivalent circuit. And we solved one problem. So this second problem we will have some more subdivisions. We try to solve in the next class.